We're going to look at some limits to infinity. So these first two in green, these are just polynomial functions. So when I'm thinking about the limit to infinity for each of these, I'm really just interested in the end behavior, so I'm going to think about them graphically. So for this first one, I see that the degree is 4, meaning it's an even degree, so the end behaviors will be matching. Since the leading coefficient is negative, that means that the end behavior to the right will be going down. So when I think about this graph, it's doing something like this. So both end behaviors are pointing down towards negative infinity. So this tells me the limit as x approaches infinity is going towards negative infinity, which we can also write as d and e. I could also have thought about this by plugging in infinity. The first term is what really matters the most because infinity to the fourth will have a greater impact than infinity squared or infinity to the first power. So if I think about having -5 times infinity to the fourth power, well, this infinity to the fourth is giving me some huge value, and then multiplied by -5 means it's becoming negative, so toward negative infinity. Let's look at this one. So again, we have just a polynomial function here. The degree 7 is odd. That tells me the end behaviors will be going in different directions, either down and up or up and down. And the leading coefficient is 4. That's a positive leading coefficient, which means as x goes to positive infinity or to the right, y should be going up toward positive infinity. So this is going to look something like this. There will probably be other things happening in here. That's not really what's important. It's just the end behavior. So here as x approaches infinity, y is also approaching positive infinity, or any infinity limit we can always write as d and e. For rational functions, so for rational functions, the end behavior is really going to be based on the asymptotes. So rational functions usually have horizontal asymptotes. Both of these do. So that's what I need to look at when I'm thinking about the limit to infinity. So in this first example, I notice the degree of both the numerator and the denominator is 3. So since they have the same degree, I'm really only interested in the leading coefficients, and I don't want to forget that there's a negative here. So this limit is going to approach the horizontal asymptote, which is occurring at y equals -15/60. This can be simplified because 15 is a factor of 60. So this simplifies as -1/4. So the limit is -1/4. For this example, we do not have the same degree. The numerator has a degree of 2, whereas the denominator has a degree of 3. Now when this happens, I'm going to think about rewriting the numerator with 0x³, and the denominator is 18x³. So when I do that, I can now apply this same leading coefficient rule that I used over here, which means I will have 0/18, which is equal to just 0. So in this case, when the denominator has a larger degree than the numerator, that means we will have a horizontal asymptote at y equals 0, so the limit as x approaches infinity is also equal to 0.